Everyone, May the 9th. Alright. Today is supposed to be go for vacation, but it was just so bad. The work just kept going on and on and on and on. There's no ending to it. Absolutely crazy. And then I still have to pack and then get ready for the trip. And then it just threw me a hard question. Jesus. A string num, a string of digits is called balanced if the sum of the digits at even indices is equal to the sum of the digits at odd indices. Return the number of distinct permutations of num that are balanced. The answer could be big with a modulo it. Alright, so we have 80, and we want the sum at even indices to be equal to the sum at odd indices. Even indices and odd indices. What the hell, man? Huh. No shit. This doesn't work anymore. I need to draw. Oh man, it's no longer usable. Oh yeah, I can't even use it. Oh. In a web version. Oh, I think it's this one. Oh, hold on a second. It's good. Some of them are not available yet. I'll delete a section. I'll do a new one. Okay, I can draw now. Yeah. All right. So basically, we have 1, 2, 3, and we have these positions and then these positions, and the goal is for them to add up equal. Now depending on how many we have, right? If we have a lot or a little bit, it's different. Even number, an odd number. If we have even numbers, we need to find half of them and then the other half. And half should add up to the same as the other half. And once we find the half and the other half, then it's just a question of, multiply them. But we need to do, it's permutation, it's a full permutation of that. If for odd, it's gonna be, even will be like 2, and the other one will be 1, right? So in this case I have 3, and I have 1 and 2. So the total is 2. But how do we find? That is actually a good question. How do we find? Like 1, 2, 3, 4, 5. So we need to find 3 numbers that adds up equal to the other 2 numbers. Okay, we add them together is equal to 15, so we say that's not possible to divide into 2. Now let's say we add up is an even number. Right, we can divide it into 2. Oh, they also could be the same. I feel like even that question alone is I don't have any idea. Not even like permutation. Just say given you a list of numbers, a list of digits. Well, but the thing is, it's only 0 to 9, so it's not that many difference, right? It's only 0 to 9. How do I find, or to put another way, if we can find a way to split into 2 groups, yeah, let's say we can split into 2 groups, is it possible that there are multiple of these ways to split into 2 groups? I don't know. So you split into 2 groups, and then one group you have your numbers that can add up to the certain value. You have another group that can add. I'm not doing this one. I'm taking the hints. What's the hints? Count the frequency of each character in the string. DP. The states are the characters, sum of even indices and the number of digits used. Calculate the sum of odd and without using a state for. I don't understand what this means. Count the frequency. Okay, let's simplify the problem. right? That simplify the problem. Use DP. The state are the characters. Sum of even index numbers and the number of digits used. Copy and paste. I'm not doing this. Jesus. If I ever have Ghana, I'll do it, but no Ghana today. Yeah, think about it. Now that you have completed states are the characters. Okay. Sum of even index number. So we are saying a number of digits used. We have used and the number of digits used. I don't understand. Oh, the number of digits used. Okay, I know what that means. So we want to find the total number of ways given that we have the states are the characters. I don't understand the first one. And the number of digits used. That means that like the digit, the specific digit that we're looking at, right? Uh, memorize the search. Oh, that's way too long. Sum of the numbers at odd indices is equal to the sum of even. So the given num, we need to find the number of different permutations that are balanced. Let the sum of all digits in num to be total. Total is odd, cannot be divided, and is impossible. Yes. Digits in num range from 0 to 9. There may be repeated digits. Let the length of num be n, and let the number of occurrences of digit I. Number of occurrence of digit I to be count. Okay. Using the principle of multi-set permutation. Using the principle of multi-set permutation, the total number of distinct permutations that can be formed I didn't know that. But I agree. Yeah, that is what we're thinking about. Yes. Oh, because there is a term for that. Multi-set permutation. Fancy. Fancy. You just you do the total permutation divided by the multiplication of all the duplicates, right? Mm-hmm. So there are two odd positions. So you take a ceiling and even positions you take. Really? I thought it should be the other way around. In some permutations, because you have 0, 1, 2, right? So ceiling and then the floor depends on what this floor means. Like 3 divided by 2 is 1.5. 1.5, floor of 1.5. I guess that's 2. Ceiling of 1.5, that's 1? No? Unless the even and odd is defined differently, but it's fine. We know what they're trying to do. Suppose that in some permutations the number of times digit I appears in odd positions is k. So it appears ki. Count I minus ki times in even positions. We aim to enumerate all valid assignments where the sum of digits in odd positions equal that in even positions. We fill in digits 0 to 9 sequentially with the enumeration process as follows. Consider digit 0. Let k0 be the number of zeros in odd positions. There are m. What the hell is m? Positions available for, okay, m is position available for odd, and the number of zeros in even positions is this minus k0 with n minus m possible availabilities. The number of such combinations k0 choose m. Now m choose k0 and n minus yes. Next, consider digit 1. Let k1 be the number of ones in odd position. There are m minus k0 positions left for odd, and the number of ones in even position is this. Okay, so m minus k0, because we've already done that, times this. For general digit I, let ki be the number of times it appears in odd. The remaining odd positions are, yeah, that's true. The remaining even positions are, yeah, that's true. The number of arrangement is this. So these are observations. The total number for valid is are you saying we can, do something about it? To compute this efficiently, we use a memorize search. Oh, that's just DP. But hold a second. Hold a second. How do you know how do you know what the K0 is? You gonna try every single one of them? That's not possible. Alright, DFS I is that, what's current? Represent a number of valid ways to fill digits I to 9. Number of valid ways to fill digit I to 9 where odd count positions remain for odd indices and the sum needed in those positions is current. The sum needed in those, so we have odd count, odd position, like we can say we have, 3 odd positions, and then we need a number. We need those to be this. We try distributing digit I by placing j copies in the odd positions. Then the number of ways to choose these j. We try to distribute digit I. Wait, what's current again? The sum needed in those positions in order to balance. The sum needed. So we basically find the difference so far. Wait, so are we filling the even positions already? The number of ways to choose these j odd positions is, yes, the remaining count I minus j copies go to even positions. Huh? Wait, what's current again? The sum needed in those positions. So we have odd position left, and we need to make them to a certain level, right? And for the current digit, I can choose j to put in those odd positions, and the remaining will go to even positions. With I don't understand. K equal to I to 9 minus odd count. Because we only have these much odd, right? And the remaining we need to fill is that sum. So, okay, that is the even positions. Okay. Number of combination for this step, yes. Because this on I plus 1. New target sum. So the target is everything in odd position add together, right? So we start from 0. The target is total divided by 2. And what's the third one? Odd count. Odd count is m, which is just divided by 2. Odd count. The recursion ends when I equal to 10. If both current and odd count is 0, return 1. Otherwise, return 0. We apply pruning during memorization. For valid ki, a number of digit I odd positions we must have so we determine the branch early. So this is the remaining even position, right? This is the remaining even positions. And this is the current count. So current count minus the even positions. What the hell is ki? For valid ki, the number of digits are in odd positions. Numbering odd positions. Numbering odd positions. It is smaller or equal to the minimum of count I and odd count. That is true because you cannot be more than that, but it needs to be larger than count I minus, what is this? This is the remaining even positions, right? Remaining even positions. Count I minus remaining even position, which means if I'm able to fill all the even positions, and that is the smallest value we can assign to odd. So it has to be larger than that. The total number of remaining digits is less than odd count. The configuration is invalid. Multiplicative inverse can be used. Oh yeah, whatever the fuck this is. Yeah, this one is I think there's also one more thing, because you have to do this part. I don't know what this part does. It says the numerators are fixed. Yes, it is possible to avoid calculating a combination number, and only the denominator needs to be calculated. At this time, the multiplicative inverse can be used quickly, calculated, and no further description is provided. I don't know what that means, but suffice to say, why do they use a lambda? I don't know. Suffice to say, the state itself it's not that bad. It's not that bad. You basically say you start from this, and for each one, I think you can do output. It's basically iterating, right? You say I'm gonna try 0, right? And I have a goal of how much odd, and you can do even as well, how much odd I need to achieve. And I can say I'll put 1. I'll put 1 in that. I'll put 1, and you say, okay, if you put 1, then the goal will change, and then you move on to the next one. Right? So you put 1, that means you put the remainder in all the even positions. So if the way the total permutation of this of total permutation is odd count j. Yeah. And yeah, this is the recursive formula. So j from 0 to this, and you do this times this. That's not bad. I think what is bad? How do we count? How do we do this? How do we count? How do we count this? I don't know. What's the trick there? Oh, we have a p sum. This is the sum from position to the end, I think. This is the number of current count position. So how many we have minus even count. Oh, okay. I'll give everything to even. Okay, so this is the number that the number of count that we can give to odd. Yes. Yes. The ways. Oh, here's a comp. Here's what comp is. Huh. Pre-compute them, huh? I don't see a pre-computation for comp though. Oh, must be this then. A choose B. That, okay, this is an interesting one. I don't think I've seen this one before. This is A choose B. So A choose B will equal to, I don't know which one choose what. I think it is this, choose this, plus this, choose this. Let me think about it. So let's say 5 choose 3. So 5 choose 3 is equal to 4 choose 3 plus 4 choose 2. 5 choose 3 shall equal to 4 choose 3 plus 4 choose 2. Why? 1, 2, 3, 4, 5. 5 choose 3. So it's like 4 choose 3, right? So 4 choose 3. But then you have an extra position. Oh, it didn't even say how you arrived there. Yeah, it is very important to understand this part. I mean, I know this must be right, but yeah, for 4 choose 3 I got everything we have. But why you plus? I don't think these are. I think this is the most difficult part. I still couldn't figure out what it means. I know what it tried to do, but is there an explanation why? Nah, I want to know why. Like, why this one works. Like, mathematically, why this one works. Is it related to factorial? Not what I want. It just say you can use the recursion. I feel like if they got it, but this add is really very unintuitive. It's like, what the hell? Why would you add? So what if we think about it this way? Right, you have 5 positions, and let's say we have only 4. Okay, and then to find all 3, that's 4 choose 3, right? That's 4 choose 3. Now for this, we're missing when the last one gets put, so we need to add the last one is put, and then would be 4 choose 2. That makes sense now. That makes sense. So okay, I got that part. And well, technically that's all there is, right? Technically that's all there is, and then you just put them together. Well, there's also one more thing, as the p-sum. Where is p-sum used? Here. Odd is small. P-sum. What is p-sum again? It's the number, the total remaining number. Okay, total remaining number is smaller, yes. Or the current is larger, you got the target. What the hell is target? Target is the target. So if it's larger than target, then these are no good. No good. If position is larger than 9, of course. Current equal to target and out count equal to 0, yes. If it's not equal to -1, we return. That's DP. Okay. Well, it's not that bad, but dude, you have to come up with this. That is pretty bad. All right. I think I understood it, although not really fully committed, but I understood what it's trying to do. But still, I think we need to figure out, like, this type of problem. Like, when I see it, I really just blank. I don't know what to do. I have no idea. Right? Actually, no idea. So the first way of simplifying an account, yes, I agree. Count is the way to simplify it. And then you just need to distribute some numbers in even, some numbers in odd. Then you just say, okay, I'll pick odd, right? I'll pick odd. I can pick even too, so that doesn't really matter. So I can pick even or I can pick odd. And then I say, okay, I have a target. Yes, yes. So you don't think about even equal to odd. You just think about you need to fit the even positions such that when you exhaust everything, right? When you exhaust everything, um, it the sum will equal to the target, right? The sum will equal to the target. Okay, and then at each round, and you say, I'll add 0 to the odd position, 1 to the odd position, 2 number to the odd position, it doesn't matter. And once we do that, right, once we do that, then we have the total number of ways is the odd position, choose that, right, times even position, choose that, times whatever the rest. So it's just odd position times, right, this is odd position you can do, this is even position you can do, which is, yes, it makes sense, right? And then we compute the even position as well. We compute the odd position and we compute the even position. This is just the total position left minus odd position left. So that's the even position, right? And then we do that. So we get, this is the current, right? The total number of ways in current. And we need to do that multiplied by the remainder. This is the remaining, right? This is remaining. And this is only when we do I at a certain number, right? You assign, like, say 1 to the odd, and then next round you assign 2 to the odd, 2 numbers to the odd, so you have to add them together. So I agree, like overall it's not that bad, but dear me, it's there's a lot of things happening. All right, so that'll be it. I'll see you guys tomorrow. Adios.